Welcome back guys, I am here with you to solve this problem number 80 of CSIR NET June 2019. So this is a question from the complex analysis. So let us firstly read it. Let real z and imaginary, okay, so these are the symbol for real z and imaginary z. Consider the domain omega, okay, so they are considering this domain, right? Now let fn z is equal to log z to the power n, where n varies on 1, 2, 3, 4, and where log is defined on this domain, okay, defines the principal branch of logarithm. I will tell you what is that. Then which of the following are true. So they are asking about the image. What will be the image of f1, what will be the image of f2, f3 and f4. Okay, so firstly see, you are given with fn z is equal to fnz is equal to log z to the power n. This is what is given to you. Okay, so you can also write this thing as n log z. Okay, this is what you can write. Now see what domain is given to you. You are given with this domain, omega is equal to z belonging to C, such that real of z is always greater than imaginary of z. Okay, so let us see firstly that what kind of region this is. Okay, so I will draw it. So let us say this line is y is equal to x. Y is equal to x means what? Y is equal to x means real z is equal to imaginary z. So this is y is equal to x line. Okay, now what you need real of z to be greater than imaginary z, mod of imaginary z. What you need real of z to be greater than mod of imaginary z. That means real of z must be greater than minus imaginary z, as well as real of z must be greater than plus of imaginary z. That means this is the reason we are talking about. Okay, on these two lines real z and imaginary z are actually equal. So on this reason we are talking about, right? So this is open, okay, because this is domain. We don't need to show that this is open because it is already given to you that it's a domain. Domain always been open and connected in complex analysis. So let us firstly see what question is asking to you. They are asking about image of this thing. Okay, so image of this domain under f1, image of this domain under f2, f3 and f4. This is what you have to find out. Okay, so before proceeding with this question, what you should know? You should know the basic definition of log. Okay, without that definition you cannot proceed in this question. So I am showing you the basic definition of log. Okay, so what is logarithm? So the function log defined on c minus 0 to c, defined by log z is equal to log of mod z plus iota argument of z. This is known as the logarithm function. Okay, so log z is defined like this. In complex analysis it's defined like this, where argument of z takes value in this domain, y0 to y0 plus 2 pi. Okay, this 0 to 2 pi is known as the branch of logarithm. Okay, I'm not going to teach you logarithm. Okay, at least you should know something about logarithm if you have done the complex analysis course, and this is the most important function in complex analysis. Okay, so I'm not going to teach you everything, but I'm just showing you what I'm going to use. Okay, so I will hope that you should know this thing already. Okay, if you don't know, you can use your books about logarithm, how logarithm was, because in this video, in this short video, I cannot teach you everything about logarithm, but I will tell you what I'm going to use. Okay, so see this. Okay, you know very well that this argument function is not continuous. Okay, it's not continuous here on this whole positive axis if you take this kind of branch. If you take the principal branch, then your function is not holomorphic here. Okay, this is not needed here, but I am telling you. Okay, so that's why they are removing minus infinity to 0. This is minus infinity to 0. They are removing this thing from your domain. You're getting my point? They are removing this thing from your domain. because they are working on this principal branch. Therefore this function is defined like this. That means your function log is holomorphic and well defined on this principal branch. That is why they have written like this. Okay, so log is defined like this, but log, to define a log you always have to define the branch on which branch you are working. So in this question they are working on this branch. Okay, you are getting my point. So I will not go into deep of this thing. I'm just showing you the definition. I'm telling you that on this branch they are working. So that means argument of z actually is between minus pi to pi. Now what is according to the definition they are giving you? Okay, I will keep this thing here. Okay, now I will write here. You need to find out f1 of omega. So firstly see what is f1. f1 of x is actually, f1 of z is actually log of mod z plus iota argument of z. Okay, so f1 of omega, they say that z belonging to C such that imaginary of z is between pi by 0 to pi by 4. This is what they are saying. Okay, now see this line, on this line your argument, that is theta, is actually minus pi by 4. On this line your argument is actually pi by 4, right? So that means that f1 of omega, on f1 of omega, because by this definition of log, okay, this definition of log, what you are getting, that whatever the argument is there, whatever the argument of z is there, you will, the resultant argument of log will also be same. You're getting my point or not? So log is defined like this. This is modulus O, right? So log is defined like this, that log of z is actually equal to log of mod z plus iota argument of z. So if you will talk about the imaginary part of log, then you will get to know that the imaginary part of log is nothing else. It's the argument of z, the element that you are taking inside your domain. The argument is taken from there. You're getting my point? So that means the argument which you are taking from here will also lie here. You're getting my point or not? Now see, in this domain your argument is between, in this domain your argument is between pi by 4 and between minus pi by 4. Okay, on this domain your argument is, therefore f1 omega will also have same argument. But because what is omega? Okay, see what is f1 omega? It's log z. So that therefore f1 omega will also have same argument. So the imaginary of this part, imaginary of z will lie between 0 to pi by 4, 0 to pi by 4, right? You're getting my point or not? So f1 of, okay, I will write here, this is same as imaginary of f1z. You're getting my point or not? This can be replaced with this thing. You're getting it now? So modulus will be 0 to pi by 4. So imaginary part of f1z, where z is taking value from your omega, is between 0 to pi by 4. That means this option is correct. You're getting it now? I will repeat myself. Okay, what question is demanding? Question is demanding that what will be the range of f1 on this omega set. You're getting my point? So now what I am telling you, that in the function log, the imaginary part is always decided from the domain part, because imaginary part is argument of z. So whatever the argument of z is here, that will be the imaginary part of your log function. Now what is your f1? f1 is actually log. That means the imaginary part of f1 will be same as the imaginary part of the element that you are taking. Okay, the argument you are taking from there. The imaginary part of f1 is equal to the argument of z that you are taking. Now since you are working with this domain, therefore the z you are taking will always have argument between minus pi by 4 to pi by 4. Okay, it's not equal to, actually it's not equal to, because this is an open set, therefore argument can never be pi by 4 or minus pi by 4. Therefore you will get this kind of conditions. You're getting my point or not? Okay, so think over it, that what I am doing, it's very easy after seeing this definition. Now see what is f. Okay, now see, I will remove this thing now. Now see what is f2. F2 is nothing else. F2 is just 2 times of log z. 2 times of log z means what? 2 times of log of mod z plus iota argument of z, but you have to multiply it with 2. So if you multiply this with 2, what you will get? You will get your argument to be in between 0 to pi by 2. This is what you will get. So argument of image of f2 will lie between 0 to pi by 2. For the third case, you have to multiply it with 3, and for the fourth case, you have to multiply it with 4. Therefore, all these options are correct. You are getting my point? Think over it. This is a very easy question, totally depending upon the definition of log. If you understand this definition, then there is no problem in finding out the range of this f1, f2, f3, f4. You are getting my point? So I will repeat the main important catch of this question. The important catch of this question is simple. It says that imaginary of fi is nothing else. It is totally dependent on the argument of z that you are taking. Now since you are in this domain, therefore your argument of z that you will take will always lie between minus pi by 4 to pi by 4. That means your fi argument of that means your imaginary part of fi will be decided by this. Okay, this is what I have used. So this is very easy question. If you are not getting it, just think over it. I have shown you the definition, and by working on that definition, you can easily do this question. Okay, so thank you guys.